Hello, good afternoon, folks. I don't know if any of you are here yet. It looks pretty quiet, but I'm running a little bit behind, so we'll just take this moment and I'll try to get set up. Um, and then you all can trickle in. And I'm going to blast out a reminder to rest of my social media so that we can hopefully get a few people more in here. Otherwise, I hope you're enjoying your weekend. And yeah, so I'm pretty psyched um, about what we're going to do today. I think last time we kind of jumped into writing the NIF before we really understood what Tree Sitter was doing and how we should work with it. And that like actually kind of held us back. So um, we will jump into that in a minute. I want to do some time, take some time to uh, investigate like what the API of Tree Sitter really is, and then try to draw an analog to what we would want to expose in Elixir. But to really get to there, we're going to have to figure out um, what like how tree sitter wants to be used, and then what kind of information we can get out of it. At In the things that I was looking at between streams, it appeared like one thing we might be able to do is take the data from the Rust API and like copy it into Elixir structs. So that you don't have to keep like crossing that boundary all the time to get information you need. But also another thing that seems really important is queries, and I think my friend Mitch, Mod on the stream, had mentioned this previously, that there's a highlights query, and so I think we'll look at that. Let's see where we are. Okay. Nobody's in here yet. Partly because I was doing some other things and dropped the ball in making the second announcement, but that's all right. Um, okay, just a few more minutes and we'll get going. Okay. So, get up my notes here. Hello, Tuxified. Welcome. Thanks for coming. And I might be the first person here, which is pretty cool. Okay. So welcome to the stream, and thanks for coming. I see a few more people. Okay, so before you all joined, I was mentioning. Hi, Frank. Good to see you. I was mentioning that we kind of need to take a step back and figure out what the Tree Sitter API wants us to do, rather than jumping straight into the NIF, because I think that like my excitement there was great. And I was like, yeah, let's do this. This is gonna be great. But then as soon as we got some of those structs returned that had lifetimes in them, and their lifetime should really live within the Rust code and not cross the Elixir boundary, because it makes things really hard, and we have to like I don't even know how we'd go about erasing lifetimes without like leaking, and that's borderline unsafe. So what I'd like to do is see, as I said, I was mentioning this before some folks showed up. I'd like to see, well, what does the Tree Sitter API want us to do in Rust? What data can we get out of it in Rust? And maybe should we copy that stuff into Elixir structs? And then if that's one possibility. Another possibility is we really focus on the query API, because I think that's probably most of what Mitch wants to do for next to LS, and look at the highlights. So I think we will start there, and it looks like looks like I think I'm ready over here. So let's get going. All right. So real quickly, my notes here. We did the parser new, and we were able to parse, but it doesn't, it returns us a tree. Like, we can't use that directly in Elixir, so we need to take a step back and think about that. And we started to get to, hey, let's go to the root node and maybe do node traversals. And that's all well and great, but that may not be what we want, first of all. So I think what I want to do is make a new throwaway project, and we will pull in just tree sitter and the tree sitter Elixir. We'll pull in those crates, and then we'll make either like a little binary or make some tests that let us play with that API and just figure out what's going on. Because I think understanding this stuff will be really informative for like what sort of API we want to expose to Elixir. So let's minimize that for now. Okay, so let's make a new window. What does Mitch want to use it for? If it's highlighting the queries, it would be useful indeed. Yeah, exactly. I think what I'm not sure how that ties into like syntax highlighting, but what I suspect he might want it for is identifying things like modules, local variable names, and so forth, to use an autocomplete. But we'll see. Okay, this is probably, let's see code, and let's do cargo new. It'll just say, we'll call it TSEX. This is an awful name, but let's see, TS fun. There we go. Okay, so this is just to make a throwaway crate. That we can have a little binary in. Yeah, okay. And actually, yeah, it's going to make a new window. Okay, that's fine. And we can close this one. Okay, so we added tree sitter and tree sitter Elixir. And let's look at the main. What I want to do in here is we're going to do, I think we'll do this as a binary first. And let's just do that because we don't care that much. Okay. So I think what this binary should do is it should take a file name. Yeah, thank you, Tuxified. If I got it right, folks, use the queries to extract where things are defined, variables, functions, etc., and then apply highlighting to whatever is found. Yeah, I think that might be really useful for the sort of where the language server identifies a problem, and it's like via the compiler or whatever, and it's like, where was this thing defined? So maybe jump to definition might be something that could help support this. The thing is, though, like, tree sitter only cares about the current file. It's not looking at the entirety of your so we might have multiple trees or whatever. But yeah, that's a good point. Thank you. Okay, so what I want this to do is take a file name off the command line, and then we'll do something like parse it as Elixir, and then we will I don't know, print out some information about it, maybe apply one of those queries and see what matches we get back. Okay, so first let's get to reading in that file. So let's see, contents, standard fs read to string, and this is going to be standard env args 1. I think args is an iterator, so I have to do nth one. Okay, let's break this out into multiple lines. File name, and we'll unwrap that. Let's do expect, because then we can print out something expected a file name in the first command line arg. I'm not going to use as great as the command line things are. I'm not going to like all those crates that like Clio and Clap and all those things. Those are really great. I'm not gonna use those because I don't want to. This is a throwaway project, right? Could not read file. Okay. So now we've got the contents. Let's make a parser, and that's gonna be parser new. Yep. And this is gonna be mute parser. Okay, so then we've got the contents of the file. Then we're gonna do parser set language, and we're gonna say okay, and that's just to make an alias there. Okay, so we've got the language is Elixir, and does this return a result? It does. Could not set language to Elixir. I probably don't need to identify these so much with expect. I could use unwrap, but I'm banking on the fact that I'm probably gonna screw this up, and so knowing which line it failed on would be really good. Okay, so now we have the parser, and we want to do parse let tree. So the text is going to be contents. I'm guessing that needs to be a ref. We'll find out. And we don't have an old tree at this point, so what do we got on? It's fine. Oh, impl as ref. Okay, so string impls as ref to the bytes, and there we go. And the other thing is that read to string probably, because the result is a string, it'll probably panic or return, an error if the contents of that file is not UTF-8. So we're probably safe on there, and we don't need to worry about using one of these alternate parse methods. Okay, so we have a tree. This is an option tree, so we need to do another expect here. Could not parse file as Elixir. Okay, good enough. So now we have the basis of we can play with the queries. Let's put here. I want to get highlights query, for instance. Let's start with that. One of the funny things about these queries, and I had it open, tree sitter Elixir. There we go. So they are scheme or something that looks a little bit like scheme. So they're technically S expressions, but if we're looking at what the highlights query does, I think what this is going to do is this is going to, whenever we have one of these keywords, the node is going to be tagged with keyword. That's how I'm interpreting this. I'm probably wrong. But then there's other things like, doc and that are more complicated. So I think we want to figure out, let's look at the tree sitter API. So we have a tree, right? And we want to see if we can take a query. So highlights query should be, so that's a static string. Okay, so let's do highlight query, and let's make a new query new, and that's going to take the Elixir language and highlights query. and that should return result. Okay, so we're going to do another expect could not create highlights query. Okay, so if we have the highlight query, this is the part where it gets a little bit weird, and I was trying to remember where it goes. Capture. So this is just information about the query itself once you constructed it. I think you have to create a query cursor. Right. Okay. We're at query cursor. New. And that is infallible, thankfully. And then you try to get either the matches. So this gives us an iterator over all the matches in the order that they were found, or the captures. So, okay, so this is useful if you don't care about which pattern match and just want a single ordered sequence of captures. Each match contains the index of the pattern that matched and a list of captures. Huh. Because multiple patterns can match the same set of nodes, one match may contain captures that appear before some of the captures from repeated. Yeah. So they're basically like, this is grouped by types of patterns, and this is like actual captures in the order they appear in the document, if I'm understanding that correctly. Okay, well let's start with matches. So the query cursor needs to be mute. And then we give it a query, and we give it a node, so we could start at maybe the root node. And we'll have to look at what this text provider thing is. That's kind of funky. It's a, this is generic over this trait. And it looks like the lifetime of that thing needs to match up with the lifetime of the query and the cursor. And tree needs to live at least as long as the query and the cursor, if that makes sense. Okay. Yeah, okay. So then let's do yeah, let's say for match underscore in query cursor matches. Okay, so it's going to take the highlight query. It's going to be a reference. And it's going to take a node. So let's say tree.root node, right? And then it's a text provider. So we need to figure out what that text provider is. Okay, so the text provider doesn't describe what this is, but there's two implementations. So it's implemented for a reference over bytes, a slice of bytes basically, and for functions where it takes a node and returns something which is an iterator over bytes. Let's look at the implementation of this. Oh. Okay, so what I'm guessing this means is, this is, if we want to get the text of that node, we have to have a way to convert back from the syntax tree into the source text. So this is saying we can give it the source text, right? So let's just do that. Let's say contents and borrow that. Oh, emoji, don't need you. Okay, So let's shorten that to M for now. And this is wrong. What's wrong here? Expended found a string. Okay, so let's say contents as bytes. And that was moved. Parse here. Yep. Let's do that there. Okay. That way it's not moved when we call parse, right? Okay, so this is just letting us get to, if we are traversing the tree, trying to match this query, we get a node. What is the actual contents of that node? Well, we need to map it back to the original source buffer. Okay, let's go back. Okay, so what does query matches yield? It's an iterator, right? It implements iterator. A sequence of query matches associated with the given query cursor. Right, okay. So let's look at query match. So this gives a pattern index and a captures, which gives us query capture. Okay, so this pattern index has to map to something in that highlights query, right? So we could do something like we've got the highlight query, right? Let's see what we could get the capture names. I think. Yeah. Okay, so maybe let's start with that. Okay. Okay. So that gives us the capture names. And let's go back to query match. So this gives us pattern index and captures. Okay. There we go. M. Okay, so let's just start with let's say something like captures for pattern, and we're gonna do capture names pattern index. I don't know that that's correct. Let's look at query one more time. Property predicates, general predicates, disable capture, disable pattern. Yeah. I'm not sure what all those terms mean yet. Okay. Let's assume this is correct, and if it panics, if it blows up, we'll know. Cool. Okay. So we've got the match. So we'll print out what the pattern is, the capture name, and then let's see what that query capture is. So it is a node and an index. A particular node that has been captured with a particular name within a query. And I don't know what this index means. This we could. Does this implement debug? Yeah, let's just print that with debug first. Node implements debug. Yep. Okay. So let's just loop capture in captures. Print line. let's do capture, right? So this is just going to debug each of those captures in that pattern. And I don't know that this is correct, but let's give this a shot. So let's make a new file here, and let's put some Elixir in it. Test file, and let's say module doc false, and let's say def exported do hello world, okay, and let's say def p private do nope. Okay, so we've got a module here, and let's save it as example.ex. Okay. Now let's try to run, and let's say example.ex. Oops. And see what we get. Okay, so pattern punctuation, and we panicked. Okay, so this is interesting. This is probably not correct. This is probably not punctuation, because you can see here that we tried to use the index operator as 24, or the length is 24, but the index is 29. So this, oops. Sorry, 1 second. I accidentally hid OBS, so I can't see your chat. Okay, so that is not correct. And if we look at, so this is a note from 0 to 9. That's probably def module, right? Given the contents of our file here, index 0 to 9, yeah, that's def module. That's not punctuation. So this sort of capture names thing is incorrect. Let's look at, this API a little bit more. So maybe what we could do instead of debugging those, we could print out some of this information about it, like kind ID or kind. So let's ignore this. No, the pattern index. And so this capture has a node in it. Let's do print line. Let's debug capture. Yeah, let's keep that in there. I don't know why I removed that. And then let's do stuff like kind, and then we'll say node dot capture capture dot node hello dot kind, right? And we'll do some of this stuff. ID. And what else is interesting? Language is not interesting. Is named. Is named. Okay. Yes, we know this is not correct, so I need to remove that. And let's comment that out for now. Okay. Is extra represent things like comments, which are okay. I wanted to say named. extra. Okay. What else? So start byte and end byte, or byte range. So I think what we should do is go, let's say, contents. And let's do contents node.byte range. And let's make sure that that's safe. Sorry, I guess I have my dash on the other window. Let's pull it over here, other screen. The problem is this is as bytes, and our original is a string. Okay, so let's say as bytes, and then we take a slice of it, and then let's see if the compiler complains about that. Yep. Capture.node, sorry. Right, so U8 doesn't do display, so we're gonna have to do a string from UTF-8. And contents. This is kind of hacky. Unwrap. I'm not going to do expect here. Okay, what's wrong here? So returns a byte slice. Can we do that with stir rather than string? Like, can we get... Maybe... Okay, so this is their own range. The other thing we could do is, since this doesn't implement display, we could do something like format it. So like debug probably wouldn't work. Let's look at format args. So that's debug. Let's look at standard format. The problem could be that I mean, let's try to print it as debug. Size cannot be known at compile time. Fun. Okay. Right. So it returns a byte slice. Byte range returns a range of U size, right? So that should be correct to index on. Slice here. So it should, a slice should impl index with range as an argument. So index is the trait that lets you pass something in square brackets. Um, yeah. Default. So index, where yeah, slice index and slice index is this trait, which should be, yeah, it's implemented interesting for range over stir. So range usize, right? So this should give us, um, you know, a slice of U8s. Um, can we just try into and see what it thinks? Yeah, it doesn't. It needs type annotations. It's like, I don't know what you want here. Um, we could say maybe two vec. Okay, so this will at least let it print the bytes. That's kind of ridiculous. Okay, so let's try this again. Remember, we aren't, and I actually want to put another print line in here. And just so we get a new line. So we're not assuming that the capture names have anything to do with the node name yet. But let's see if we can get some stuff printed out. Okay. We got a lot printed out. Okay, so here, if you've done Elixir or your Erlang brain, that looks like a char list, doesn't it? That's unfortunate. Okay, so now actually I want to circle back and go. Can we do string from? Because that should panic. Yeah. So we say from UTF-8. I think we can do unchecked, but it's unsafe. Yeah, let's use UTF-8 and then just unwrap that, because we know it came from a UTF-8 string. It has to be able to go back into UTF-8 if tree sitter is worth a damn. Okay, so that wasn't all that useful. This is probably end. No? Maybe? Probably. Okay, cool. So this was the highlights query. Interesting. So these are registering as different patterns. Capture index 16. We had def module only once. Let me shrink that down to a little bit. Let's look at our example. Okay, so why don't we, we gave up on this pattern index. Let's put that back in here. Pattern index. And then we can get, maybe there's something interesting about what that pattern index is in the highlights query. Okay, so we've got for this first pattern is an identifier. It is a named node. It is not extra, and the contents are def module. Okay, and we get a different pattern also matching that. So this is pattern 16, and this is pattern 0, right? Interesting. Okay, so we got def module twice, And then we have another pattern. So this is an alias. Okay. So modules, aliases, makes sense. So test file is the name there. It is a named node. And you can see we're getting the indexes into the content. So line 0, column 10, line 0, column 18. Okay. So, oh, and you can see here actually the node type is printed there. So identifier. And I'm wondering if that actually comes from the highlights query. So let's have that open. Yeah. So let's see if there's a identifier. So there's one. Yeah, that's module attributes. So those are just matching on kinds of nodes, I'm guessing, that are defined by the okay. Interesting. All right. Let's look at some more of this, see if we can make sense of it. Okay, we've got def module again, test file. We have do. So this is not a named node. It's not an extra node. But yeah, kind ID 91. What I'm guessing is that those IDs come from the grammar. In our example, we didn't. Okay, so here's an @ sign. And remember, extra, I think it was saying these are like comments or whatever. But we're not concerned about comments really. I really would love to know what these indices are. Whether that's in the entire tree, which wouldn't make sense because this should be like the second node in the tree or something. Or if those are coming from the query file. Probably comes from the query definition. Okay, so interesting thing here. Yeah, so like we're getting different indexes for the captures, but we get the same node. So this is like a query in the file could capture a node more than once. Okay. And here's another identifier, named true. Okay, so module doc is not an extra. Okay, so it does look like when it's an identifier, it's always 129. These other things may be special characters or something, are different. So like do has its own kind ID, but up here, alias was 7. Up here, def module was an identifier of 129. So even though that was different text than module doc or false, it comes out as the same node kind. That's interesting. Okay. Okay, so Boolean ended up as 130, not identifier. Sorry. So that was a special kind. Yeah, and we're matching here again. So it's interesting. It's kind of going both in document order as well as different patterns. Okay, so let's take a. Oh, huh. Okay, I was going to take a step back because we have this captures for pattern. I maybe want to highlight that a little bit more, and we haven't. We haven't recompiled this yet, so we're not able to see what this pattern index is. But these captures are for the same pattern. And I don't know what this, if this index is like what it's referring to, because they were 1, 2, and 1 again. But these are all captures for the same pattern. So let's clear this out and run again, because we are, yeah, okay. So okay, so you can see like we're getting multiple patterns multiple times. That is interesting. Okay, so pattern 21. Let's see if we can just pattern 0. That's the first one, right? Like that's got to be keyword, right? Do is a keyword. Okay. So what's interesting here is let's go back into our program and print out those capture names. So we did this, right? Um, but let's do that. And then maybe we can sort of see if we can relate the the pattern indexes to the capture names. Although we already kind of proven that that's not correct, except that maybe there's something else correlating these things. Okay, clear it again and run it. Okay, what are our capture names? So we got key, so that we already identified, right? Keyword, comment.doc, comment.doc attribute. So that's the document. Yep. Attribute, operator, constant number, module, punctuation, special, embedded. Okay. Yeah, so we got pattern 29, but we know that there aren't 29 capture names, right? That's interesting. And there must be something where there are sub patterns. All right. I think we're learning some things. I'm just not sure if it's telling us yet what we want to know. Um, okay. And we may have to look at the C API of TreeSitter to understand this. There's probably better explanations in there than there are in the Rust documentation, and I think we may have to jump over to that, because this is like there's very little here. Okay. Capture quantifiers. So there seems to be a difference between captures and patterns, which I guess makes sense. And we need to see what constitutes a pattern. So like I think this is a pattern, but there are potentially captures inside these operators, right? Um, what if yeah, let's pick something low. So 0 is not that helpful because def module, not def module, do matches a keyword, right? Um, def module matches as an identifier. I wonder if there's some relationship between pattern 21 and module. So let's have a look. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there's something alias 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay. So this is a definition keyword. Okay, so this is a target identifier keyword. It should match keyword and then have, this is a predicate of whether this pattern matches. Okay, so this call must be building up more complicated patterns. Okay, so this pattern is definition keyword. One thing that's kind of bugging me about this is we don't actually have, based on just this. Hi Mitch, thank you for coming to the stream. Based on just this queries file, there's no like, I mean, yeah, we get these sorts of aliases or these capture names, right? These are coming out in our, right, so like string escape, string special symbol, etc. These are coming out as capture names, but not all the patterns have captures, right? So if we're just getting pattern 21, which is def module, we just figured out that that's this, hey, this is a definition keyword, but there's no sort of name for what this thing is. It's just you matched pattern pattern 21. Okay. So maybe let's go and see. So this is, if this is 21, this is 20, this is 19, this would be 18. So let's see if we have a pattern 18, because that would be captured as string, right? And we definitely have some strings in the contents. Oh, yeah, Mitch, we're just trying to figure out what the tree sitter API gives us, so that we can kind of make something useful based on the queries that are there for each language. Because when we were looking at, let's just walk the tree itself, that's really hard to expose usefully to the Elixir API without a whole lot of trickery on the Rust side. Partly because those iterators and things have lifetimes which should expire, sometime within the same scope and not like crossing the Elixir boundary too often. So I thought, hey, maybe what we should do is look at, can you execute a query and get back some useful information, and then we can copy the relevant information into an Elixir struct that you can just like iterate, maybe like a list of Elixir structs you can iterate over, or something like that. So we're trying to learn about queries. Cool. And if you have done anything with this before, please say something. Okay, so interestingly, like string or char list also matches string, as well as this special one. So we might actually want pattern. This is 21, 20, 19, 18. We might want pattern 17 for the strings that are in our example code. So just for reference to example, so we should see hello world and nope as this string node, the string capture. Okay. And that should be pattern 17 or 18, right? So let's go down and see if we can find pattern 17 in here. Da, 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 da. I didn't see it. Now, it doesn't guarantee that these captures are in order, right? Um, See, here's pattern 17, hello world, right? So that is something we expected. Let's see if we find another 17 for. Um, yep, there's another one for our other string that's in the file. So I've just written queries for NeoVim related tree seeder things. Okay. So then I guess then maybe what we want to do rather than saying, hey, let's just use the highlights query, is provide a way to, given a query and a tree that you've previously parsed, or maybe even the contents, like take it even higher level, but we'll see. Um, Return some structure that is like pattern index plus captures, where the captures, are nodes. One thing I'm not clear on yet, which we need to look at again, is what is this index in the query capture. Let's see one where it had multiple indexes and see if we can track it back to something useful that makes sense to us. Okay, so this string matches, this string node matches pattern 17, which we saw before was the string or char list, right? Okay. The index is 12. Which I don't know what that means here. Is that the capture? Oh, that's the name of the capture, right? So if we can be sure that these never, right, because hey, def module keyword, right? So this is the capture index. Okay, let's enhance our thing in here for a second. Let's do capture name, and then we're going to say capture names, and this is capture.index. I think this is what this is. Oh, no, it's not. I mean, we could do as usize, but let's try that. I think this might panic. Or it might just be incorrect. Right, so end is a keyword, right? That makes sense. This is a string, right? Do is a keyword. This is a variable, private. Yeah, that's interesting. I don't think that's correct because that's the name of a function. It shouldn't be considered as a variable. Except for the cases of highlighting, maybe. Oh, note that it's also registering as a function. That's curious. Okay, we know def p is a keyword. That's correct. I'm just interested this didn't panic. Maybe we need to put something weirder in here. So no, yeah, def p is a function and a variable. That, I don't think this is correct. I don't think this is correct. I might be being enticed by that, um, and it's not clear what that capture index is. So okay. Let's throw in a different thing in here. Let's say this is a, well, it's going to, let's capitalize that, and then it'll, oh, nope, dash, no way. That's going to be okay. So what I'm trying to do here is get it to trigger one of these other queries. So like string special symbol, atom or quoted atom. I want to have it trigger quoted atom. See if that does anything. Okay, so we get quoted atom. Cool. That is kind 133, index 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's exactly what we wanted to trigger. So maybe this index does indicate, because it's a capture, it does indicate the capture name. It's really interesting to me that this applies to, even though the node kind is, of a particular value, that the capture could be different things. Okay. So, yeah, let's say node, and then we'll do capture names. This is capture.node. Capture names, capture.index as usize. It is interesting to me that at that boundary they didn't turn U32 into usize, but maybe that just means that you can do at most 4 gigs. So, yeah, okay. So we're I think we're getting somewhere. Right. So this is string special symbol as we expected. Um, this node end is a keyword, right? Is a keyword. Okay. Now we could also do, instead of the matches query, we could also just do the where'd our query cursor go? We could do the captures query. So rather than worrying about patterns that don't have captures, we could just iterate over the captures in order and see what that produces, right? So this produces query captures, so we're not going to necessarily care about which pattern. Now that may not be as useful now that I say that, because remember that, no, I take that back. Let's see what query captures produces, and I think we can do the rest of this. So what it iterates over is a query match and a usize. And that is probably query match and a usize. Okay, let's comment this out for a second. Actually, let's see if Z and extract into function. Thank you. And let's rename that. Let's call it do captures because I'm feeling lazy. Okay. Or no, this is do matches, right? Do matches. Okay. So, and then we'll comment this out. And this is probably complaining about aliasing. Okay. Yeah, let's. Yeah, okay. So we'll maybe return to that later. I just wanted to like capture that we had done some of this down here, and we can refer to it. So now I wanna iterate over captures, right? Inquiry cursor dot captures. So we'll give it highlight query, and that's going to be a reference again. And we give it tree.root node, and the text provider again is contents as bytes. Okay, so this is a different kind of iterator. It's returning tuples of query match and usize. So this is a match, and I don't know what this is. Right? Maybe let's do this up here. And we had this query match pattern index captures, right? Maybe what we can do for now is just print out everything rather than going into this detail about what these nodes are, like we did for the matches iterator. Maybe we can just do something like this for now, and see what it prints out, and then we'll go back and maybe fill in some more detail and see what we can learn. Yeah. Okay. So yeah, we printed the capture names. So we're getting the pattern indexes, but we don't actually care about them. So these are the captures in order. Right, so we get what I'm curious about is where does this usize bump up? When does it, that second element there, the I that we're getting. So here we're getting a match with a bunch of captures. So line 1, column 2 to line 1, column 3, that's the at. Line 1, column 3 to line 1, column 12, that's the module doc. Interesting. Yeah, I think I need to look at so it's interesting that it goes in the middle here. It jumps up to 1 and on a couple of these lines, and then it goes back to 0 and then 2 right, and then it goes back to 0. It's really not clear to me what that second thing in the tuple is. Okay. Iterate all the individual captures in the order that they appear. This is useful if you don't care about which pattern match and just want a single ordered sequence of captures. Okay, but you're also giving us this extra goop, which I don't understand. Let's look at the source for this. Okay, so it's capture index. That's so why are these all 0? That is really bizarre. I mean, what we could do instead of this is we could say capture names I, right? Um, okay. Notice it skips, and those don't necessarily come out in the same order. Yeah, I don't think that's actually correct. Don't think that's actually correct. Let's run it though. YOLO. Okay, we're getting keyword, keyword, keyword. That's fine. That makes yeah, that makes sense for that def module, right? Even though it's different patterns. This is not correct. It is not a keyword. Ah. Okay, so that was a bad assumption. Okay. Yeah. The thing here I'm wondering is, um, let's maybe go with our first one. So let's forget this. And we want to do this, and I'm going to remove this, and we'll just do let capture names highlight query dot capture names. Okay. And let's change that. Okay. So here, I think what we could do is potentially, because this is not telling me anything interesting, right? Um, what we could do is make an API that lets you hand a query, um, and so not a query, but like the text of a query, and a tree. And then what we'll do is we'll create some Elixir structures. We'll do them as Rust structs first, and then we'll implement Serday serialize for them, and then just give you back, everything that's in this. So like we could do a matches map collect, and then and inside the map we'll do stuff like construct the get the information out of the nodes, construct the matches as Elixir structs and so forth, and then like return that. I think that might be useful because I don't really know, and Mitch, maybe you can jump in here and say, hey, I want this, but I don't really know what we want to be returned to Elixir yet. So the thing is, it's going to be a little bit expensive. We won't be able to get sharing. which I think is okay. Um, but we might. That's interesting. If we're getting binaries from Elixir as the contents of our, it won't be a string. We won't be doing this goop. We could do sub-binary sharing potentially. I'll have to look into that. That's probably an optimization that will make this a lot better. But yeah, so okay, I think we have some information here. We can switch gears and go back to the NIF and maybe implement a query and do it generically enough that like you could pass the highlight query that comes from the crate, or or just pass your own thing. Um, Real quick, I want to look at the other queries in here. So like injections is interesting, doesn't really tell me that much, but that's like, is this an a HEEX template? I'm guessing. No, we'll see about that. Tags is probably more maybe what you want, Mitch. You say module and protocols, module definitions, function definitions. So tags is sort of the thing like you would expect with a tags file in old Emacs, where like it would index your code base and help you find things. Yeah. Okay, injections are for switching parsers, mid parse. Good to know. Okay. Yeah, well let's start with making those structs, and I didn't mean to minimize that. Give me a second. Okay, yeah, let's switch over to the other project. Let's forget the NIF stuff for a second, and let's go and start making those query structs. Yeah, I know they aren't a core tree sitter concept, but like I was trying to explain what that query was doing for the caller. Okay, so let's make a new file here. Let's call it query.rs, and we'll do mod query. Yeah, that would come after p. Okay. So we're going to probably have to add. I don't remember what the state of the art is for Serday and Rustler, but let's just look it up. Okay. Oh goodness. Right. So this is kind of what we want. Right. So that's old syntax. That is not correct. But it looks like we can do. So Serday rename, we give it the name of the module. So what I'd like to do is yeah, let's make some like very basic structs in Elixir and make their analog on the Rust side and do Serday stuff between them. Okay, so rather than just a map with struct, you must tell Serday to rename the struct to the full Elixir struct module item. Okay, so yep, let's go in here and we'll get to this in a second, but we need to add. We need to add Serday and Serday Rustler to the project. Oof, okay. right, looks like Saturday Rustler depends on... Let's see, it may depend on a version of Rustler sys that is incompatible. I wonder if this is... That's 3 years ago. Yeah, so it's depending on Rustler 21, and we're already at like something higher than that. Oof. I thought this was going to be easy. I wonder if it's that way because we have something in Rustler itself now. But yeah, I mean, this is not surprising. This is kind of what I would expect. That's, yeah, fine. Okay. So what I'm going to do rather than that, yeah, let's clean that up because we can't. I put Rustler sys at star because I didn't know, which version we were going to be using, but and we needed it in one of our files, I think. Yeah, I think that's not going to work. We're going to have to do something else. So let's look at the Rustler API. Okay. Yeah, that doesn't tell us what we want. All right. Let's jump here instead. Because I thought that there was a way in here that it was right. So this X struct, and maybe it's this encode decode thing. Maybe what we need to do is, yeah. I remember now. We need to look at the encoder, the docs for the encoder. So let's do docs.rs Rustler. Let's look at that. Okay, so I don't remember if there was a derived macro or anything. Oh yeah, it's this stuff. Yeah, not Saturday. Silly me. Okay. So we'll use NIF struct because before, remember, we used like NIF unit enum on one of the other things. So we'll use NIF struct, and then that way we can create these things and just pass them back to Elixir and see what we get. Okay, so yeah, let's get started on that. So we need to use Rustler star again. I don't know what we're going to need yet. And we had so we had to get a tree and have from parsing, right? So we don't want to create this. We just want them to pass the actual text of the query, I think. And then we want to do something like loop over the matches. So we're going to need something which is relatively like query match, and something which is like query captures. And then we will, look at the nodes and see what we can create for nodes. So yeah, let's make a struct. Actually, let's not import all that yet. Maybe we'll use it qualified because I'm going to want to name some things the same here, and I don't want to conflict. So we'll have, oops, we'll have query capture. We're going to have a query match. There's going to be stuff in it. We're going to have a node. Let's call it query node, just to distinguish it from the one that's in the in the tree sitter library. And yep. And let's look at this derive. Right, so you give it the module name. Okay, so we'll do, even though these don't do anything yet, we'll do, and I was actually being concerned about the wrong thing. We can use wrestler star. So we're going to say NIF struct, and then we'll give it the module name. Right, module equals, and this is going to be tree sitter dot query capture. And we'll do something similar for these other two. And I might just call this node because we're never going to be able to expose those borrowed nodes directly. So let's remove that. Okay, and then we need in our Elixir source, let's make a new file over here, and I'm just going to put all of these in there. And then as we develop the Rust API, we'll mirror the attributes of these structs, these fields of these structs over here. So tree sitter dot query match, and this is def struct, and we'll do like that, and let's just copy paste that, and we'll say query capture, and this will be node. Eventually, I think we might want to do something like tree, wrapping the tree so we have the resource kind of hidden inside the struct, and we can be a little bit safer on that end, as well as with the parser. But yeah, we're not doing that yet. It's fine. Okay. Okay, we can close the parser cargo tunnel, and we don't need that right now. Okay, so let's look at what we were doing over here again. So again, we're going to give the pattern index. That's going to be a field. And let me just do something like this, even though there's not much screen space. We'll make that a little bit bigger. Okay, so we need a query match. It's going to have a pattern index. And that's just going to be dependent on the user submitting the query to know what those indexes mean. We know we can't determine for them what that means. We can, however, name the captures. Okay, so for each capture, let's say, so there's going to be a node, and then let's give both the capture, the index, and the capture name. So we can at least pull that out for them, like we were doing here, right? And we'll give the index just for for the sake of being nice. Okay, so the node, let's give the kind, which is going to be the name of the node kind, right? And let's give the kind ID just for completeness. And we can do named question mark, right? We can do extra question mark. I don't know what else is going to be useful here. Let's say text is the first thing, and that'll be this goop. And real quick, let's look at anything else on the node. Nope, here. What else is on the node struct that we can might be useful? Language, we know what we parse it from. We don't need that. Is error might be useful. We probably byte range. So maybe we can construct an Elixir range. Or actually, we want to make an analog for this tree sitter range. That might actually be more useful. So let's just say we're gonna have a range field, and that we can make an analog for that over here, and just copy that stuff. Okay. You know, start position's not that necessary because range contains, yeah, it contains those. So we'll make a point struct as well. We're not going to get any of this accessor stuff. Child count, I don't know. Like a lot of this stuff may not be all that like useful for our query thing right now, and we can come back and revisit it. Not going to do that. Not today. Yeah, those are all traversal things. This is interesting. I wonder what this does to S expression. Oh, well, what the? Why did I make this so hard? Remember what I was doing with all that? Give me the bytes and then like flip it to, you know. Yeah, I could have done this. UTF-8 text. Such a bonehead. Okay. So maybe what we'll do is in our implementation, we will do this and then like try to call to-owned on the result. Yeah. Okay. So right. Yeah, I don't think there was anything in here that we needed to add that we didn't already have in there. Because we're going to give the range, right? And the range is going to be our own struct. So let's go ahead and mirror that struct. Tree sitter range. Range. Gotta remember which language I'm in. And this is going to be def struct. Start by, end by start point, end point. That needs to not have a trailing comma. And then we'll do, because those are going to be points, we're going to do that too. Look at point. Row, column. Easy peasy. I suspect that like this stuff is going to be important for your language server. Okay. If you're still here, Mitch. All right, so we need to make these things, and let's hide that for a moment and get a split going on here, so that we can have the Rust code and the Elixir code side by side. Okay, so query capture, we're going to say pattern index is usize. And pub captures is going to be a vec of is going to be a vec of, oh, did I get this wrong? This is query, I was working on query match. Let's move that. Oops. Query match. So this is going to be a vec of query capture. Okay. And then query capture is going to be node is going to be, this is going to be the node. Excuse me. Index is going to be usize, and capture name is going to be a string. Okay, and then node we need text is going to be a string. Yeah, it's going to be a string. Range is going to be let's be one of these, right? The thing is, I don't want to, let's say self range. I don't want it to conflict with the standard library range or the tree sitter range. But we'll get to that. Okay. And kind is going to be a string. Kind ID is going to be, I think it's a U32. We're gonna have to look. Tree sitter node. Kind ID is a U16. Okay, no problem. That's a static stir. Yeah, we'll just call toOwned on it. Okay. And then, and what might be cool is we can do some from implementations to take the tree sitter library structs and turn it into our own, which would be pretty cool. Okay, I can't speak to the actual reasoning, but in the NeoVim tree sitter implementation, I have range 2, range 4, and range 6 objects. Okay, yeah, I don't know what that would mean in this case. Like, there's, I'm assuming this is range 6 because there are overall 6 fields. There's a, bytes and points with row column. Yeah, that's kind of weird. Thank you for that information, though. Okay, and then we wanted pub named is a bool and pub extra is a bool, and we're gonna have to rename those fields, I think. Let's see, or we'll just change the Elixir code. So yeah, those don't have to have question marks on them. Let's however put is in front to make clear that it's a Boolean, and we'll put that here too. Cool. Yeah, and thank you for making that point about the name concern. I'm more concerned with conflicting with the standard library or with something in Rustler than I am with conflicting with tree sitter. I think we can pretty straightforwardly deal with their stuff. NIF strict, yes, I want to be strict about it. So module is tree sitter dot range. We need to define that. Obstruct range, and then we need to do the same for point. This is pub row point usize. Nice. And so normally I wouldn't redefine this, but because of the orphan rule, we can't define encoder for tree sitter point or tree sitter range. Um, yeah. Oh yeah, I see what you mean. Range 6. Yeah, I think though, like we are namespacing these. I'm not concerned. Like somebody should always say tree sitter range, and when we print it out, it should say, if we're like doing IO inspect or something, it should say tree sitter range. And I don't think that anyone would be confused by the inspect output of this versus the inspect output of Elixir's range, which I think puts the dot dot in there. Okay, so yeah, and we need this. No, start byte is going to be. Those are all usizes as well. Usize. End byte is going to be usize. Start point. Point. End point. Point. Okay, so now what we'll do is I'm going to do tree sitter point for point. And I don't, yeah, yep. I don't have, because I'm in a mixed project, I'm not getting the Rust analyzer working correctly here, so I'm just going to have to I'm going to do this. And actually, we're going to do, no, it's fine. We'll do row, column, do a little destructuring here. Nah, never mind. I'm being too lazy. Row, p dot row, column, p dot column. Okay, so we have this implementation of from for point. We can do the same for range. And this will make it easier for when we do a query, we can just like call into everywhere that we want. And we may want to do even from references, but let's see. I'm not sure yet. Okay, tree sitter range for range. I think it depends on the calling context and whether we have ownership of that. Cool. Okay, so we're going to construct ourself, and we'll say start byte is r.startByte, end byte, r.end byte. And this is the sort of code that I would rather not write, but we are going to take the hit for the sake of usability. Now, note here, if you're not familiar with this bit of Rust, because I implemented from for point already, I can, for each of those fields, the start point and end point in the tree sitter range, I can call into on those, and it will call this to construct that for to fill in this field. Cool. Okay. And now we're going to have to do some fun from tree sitter node for node. And let's just get that. Self. Okay, so now we're gonna, for nodes, we're gonna do basically what we did in this other thing. We're gonna pull out those fields, right? Except we don't have, oh no, wait. we're going to need more than that because we need the original text. We can't. Yeah, that's not going to work. So because if we're over here in Node and we call that UTF-8 text, we have to give it the source. Excuse me. So it's not going to be sufficient. Let's abandon this for now. And we'll make a method on there or something like here. Let's just go ahead and do that. Say from node ts node, then it's clear it's tree sitter. Okay, so this is going to be we're going to need the node. Yeah, the node is going to be tree sitter node. Generic over that. And actually we probably don't need it out here. We can just say it'll take any lifetime. And then we're going to be, the source is going to need to be a slice of U8, or maybe it can be impl as ref U8. Okay, and I'm going to need a little bit more space there, buddy. Okay, so now we have the node. We can do this stuff for it. So we could say let range node dot it was just range, wasn't it? Yep, range dot into. Haha, there's our into showing up. Let kind equals node dot kind, and that returns a static string. So we can call toString on it. Let kind ID is node dot kind ID, and I'm just doing this up front. We could have done it inside the construction, but as named node dot is named, and okay. Now we can do. So what we want to do is let text is node. And this is the thing I was trying to call earlier, UTF-8 text, and we give it the source. F8 text. And it's going to give a result of a string, and I actually think it's fine to panic here because Elixir programs have to be UTF-8. I don't think that's a generally good thing to do. We could say a result of self here. This is probably good enough for now, and I'll put it to do in there. So this is going to return a result of aster UTF-8 text, and it takes source.asref. Okay. And then we can say expect, we'll say a node had no UTF-8 representation. Syntax node. Okay, and then we can say self and just do text range kind ID is named is extra. Okay, so this is a pattern I've sometimes done in my work stuff where there's no, like, you want to implement from, so you can call dot into, right? But you need something extra than the thing that's being converted. You have to do something like this. So yeah, and I actually want to do that. I don't think that we need to consume the node, and that's already a reference. So yep. Okay, and then yeah, let's look at. Let's see if we can implement. Yeah, we're gonna have to do the same thing here, right? For query capture and query match. And I actually want to reverse these because query match is the thing that we are the top level thing. Okay. I actually want to make that pub for now. Doesn't really matter, we're in the same crate, but okay, so from TS capture, and we're going to say the capture is a tree sitter capture, query capture. And does that have any lifetimes on it? I think it does. Indeed it does. Okay, so we'll put a tick underscore on that. And here we want to get the capture name, so we're going to have to get a reference to the query, right? And then we also need the source to pass through. So yeah, that line's getting long. I think we can close that split. Okay, so we need the source, and we'll do that impl as ref u8 again. So just to be clear, we're trying to build up this way to construct these from that this like iteration that we did over the results of calling this matches. That's our goal right now. So we've got a query capture and the original query. So we're going to do names, capture names. Is going to be query dot capture names, right? Yep. And that gives back a slice of string references, if I recall correctly. So let's look at that real quick. No, just gives back a slice of strings. So it probably does the copying. No, okay, I get it. That's kind of a weird thing to do, but okay. Okay, so we have the capture name so that we can give. So let's do let node be the capture dot node, and we'll say node from TS node, right? And then we have to pass the source here. So that's this thing we implemented right here. And we probably need to do that. And yeah. Capture name, we can go ahead and do this because we have capture names, capture.index. And let's clone that just to be clear that we're taking ownership of that string. Yep. Okay, I'm hoping by I want to wrap up probably within 30-35 minutes. I'm hoping by that time we can actually get some like Elixir output from this stuff, but we'll see. We're writing a lot of Rust right now. which I'm okay with. I am enjoying it, but I also want to give you a little bit of, well, what does the integration actually look like? So I think that's important. So let's construct this. So the node, we have the capture name, and we can put the index in there, capture.index. And that is copy, so we don't need to worry about it being reference. What are you complaining about? We'll figure it out later. Okay, we're almost to the top here. So this will do something here that's very similar from TS match. And here we're going to need the query and the source again. And we'll need the match. Except, let's use a trailing underscore. Query match. And I'm sure that's going to have a lifetime in it as well. And we need these other things. And then we're going to do self. Copy pasta on line 4. Line 4? Thank you. That's query match. Good eye. This is why I do mob programming. Thank you, Isaac. Okay. So we have to do something similar to what we did before. So let's do let captures is going to be match dot captures into iter. Actually, it's going to be iter because we're going to be borrowing from it, right? Let's look at query match. So it has captures, right? Okay. It'll be, that actually has 2 lifetimes. But we still don't care what those lifetimes are, right? So it can constrain those however it likes. We don't actually care because we're copying everything out of there. Okay, so then we're going to map that through, so this is going to be capture C. We're going to say query capture from TS capture, right? And that's going to take C and query and source. Now, the interesting thing here, we should, let's do source.asref here, because what I'm worried about is honestly, I'm trying to be too fancy here. I think I can probably just do slice of U8. And then because, references are copy. Copy in the sense that it's copying the pointer, not in the sense that it's copying the structure that pointer points to. I think I want to do this because then these will simplify and we don't have to have these as ref calls. Yeah, this is a you ain't gonna need it situation. I think that's that's the limit of it. That was getting too complicated, and the main problem here was Well, I'm trying to loop over these captures and create my own structures from them, but this source was going to be moved into that or needed to be copied or something. And if it's just a reference here, if it's just a slice, then I'm not worried about it. And we can go self pattern index is going to be match underscore dot pattern index, and captures. Okay. Let's rename that. Oh, you're not going to work, are you? Not anymore. Can I replace? Oh. Toggle replace. Okay. Match with TS match. Replace all. Thanks. Okay. Match being a keyword in Rust makes that a little bit hard. That's why I put the underscore on it, but like I really didn't like the look of that. At least if it's TS match, it kind of, you can go, oh, from TS match. The first argument is TS match. Okay, that's the thing. Okay, this probably doesn't work. We're gonna find out. And thank you for pointing out the copy pasta issue. Let's make sure real quick those actually match up with the Elixir module names we want. Yep. Tree sitter node, tree sitter range, tree sitter point. Okay, so now we've got these structures. We want to make a function that does something similar to this, right? So let's make a function query matches. And what we'll do is we'll make one in the NIF binding as well. I wanted to kind of keep the external interface separate from the internal one. So let's do similar to what we did here. So we're going to take, this is going to take a query. Let's see. Let's do it. Let me take that back. Let's do it from the top down. So again, let's make a dirty CPU NIF. I don't know that it needs it, but I think it's smart because we're going to be potentially doing a lot of copying of this stuff too, stuff out of the tree sitter structures into our own things. So that could potentially take a while. Query matches, and we will need okay, so this returned a tree. So we need the tree, which is going to be a resource arc parser tree, right? And then we need to, and this is going to give query matches, right? That's what we want our thing to do. So we needed the tree. And what else do we need over here? So we've got the tree. We need the query itself, which is going to be some text. We need the language. So I think we probably need to pull that off of the tree itself. It does not include the language. Okay. What did we do over here? Well, we can do this, right? We can do the same thing that we did here. Okay, so the tree, we need the language, which is going to be our enum that we made last time. And we're going to need the query, which is going to be binary. Yep. So we're not going to be responsible for reading files. We may want to provide a way for someone to get the queries for a particular language and we return them as binaries or as a map of here's the name of the query and the binary. Maybe we'll do that next. But let's assume for now that they're going to pass in the query and we're just going to return the matches. Okay. Yay, formatting. Okay, so we've got the tree. What we want to do, let's do what we did up here. So let's get the, and this probably needs to be NIF result, right? Okay, because we want to be able to do that. So we've got the language implementation that gives us the actual tree sitter language. And we've got the tree, so we just have to construct this stuff. And yep. So we'll make the query cursor. Let me bump down the size of this so we can read it and have our code up at the same time. And this is going to be similar to what we did in here, right? So did we make the cursor here? Yes, we did. Probably didn't need to. Okay, so let's make the let's call this query text or query raw, and let's go. The query is query new, like we did here. Did we import all of tree sitter here? No, we did not. So maybe some of this needs to go down a layer. Let's just do this and go query matches, and we'll give it the tree, the lang impl, and the query raw. And then this, let's actually say this will be, what did we do up here? As slice, right? Then it's a slice of U8s. Okay, and so we need to implement this function. And I was about to do that here, but yeah. Okay, so the tree, I think we want to unwrap that resource arc. So I think we're going to use deref on it. Tree is going to be oh right, yeah, so what we want in here is we need to lock that. Right, because this is a resource. Okay, we've got to, oof. Not fun. We're gonna have to expose the text guard, right? I don't really want to do that, but now it does deref, so maybe what we can do is, yeah, maybe what we can do is say this is tree sitter tree. Because mutex guard will deref to the borrowed value that's inside the mutex, right? So I think that probably what we can do here is say that, and this is tree sitter language, and the query raw is going to be slice of u8. And this is going to return vec, and here's where we need to fix this. This is going to be okay. This is going to be a vec of query match. Oof. Okay, are you going to format for me? No. I've got something else wrong in here, so it's not happy. Okay, so over here, we need to do this, borrow the value that's the result of locking it. And I kind of, maybe at some point we will switch that mutex to a read write lock, and then we can do something like, take a read lock rather than a write lock. And those really only need to be mutexes because who knows what thread this is going to be run on next. Thanks, Bean. Okay. So because I really don't want this in here. I really don't want to care about mutexes in this file. It only cares about, hey, I've got a tree. Let me do the query. And we'll borrow that. Okay. So we need to do what we did in this other file, like this. So we've got the language and we got the query. And I'm going to, I don't know that panicking is the right thing to do here. Let's think about that. So maybe this needs to be NIF result query match, and then we'll figure out how to do that. Okay, so let query new. It's going to take the language and no, it needs to be owned. Okay, that's fine. And it takes the source, which is a stir. So we're gonna have to, let's look if Rustler does anything for us here. Probably not. So types binary is a thing. Earlier in the stream I was talking about subbinaries. We could do something like that, but we are not bothering with that. Yeah. Okay. So we're going to let source, because binary can, so we were doing as slice, which returns the U8 slice, right? Which is fine. But now we need to do string from UTF-8. And I could do it unchecked, but like I really can't justify that. So we're going to have to implement our extension trait for this result here, so that we can do, let me see, with NIF error, like so. And then we'll have to do the same for the error returned by query. So Let's look at from UTF-8. Returns UTF-8 error. Yeah. Right, we already did it for some of this stuff. So we can say impl, and I actually have a bug here. Because the lock could be poisoned, in which case we need to convert that. I think we did it up here. Where did we do that? Okay, I don't know. Oh, is probably parser? Parse? Imagine that could potentially return something. Right, right. That just returns an option. Never mind. Okay. All right. So we've got that converted. Let's get this. We don't need the impl t. Impl into NIF error. Now we could potentially do something like that might actually be clever. Impl t where it implements standard error. Because this requires debug plus display. So we know that if it's an error type, if it implements standard error, then we'll just get it. And let's kind of do this. This is basically what we want. And I think that probably what will happen here is that we're going to get conflicting implementation for this. So thank you. Nice to see you. Come next time. Okay. So we might actually not need to have some of these implementations. We might not need this one. We might not need this one. Let's check really quick for tree sitter language error and see if it implements error. It does. So we could remove that. I think what I wanted to do originally was be really explicit about it and only implement it for the things that we actually care about. But if we're using this in our code, then we should definitely, yeah. And I think I'm pretty sure standard sync poison error implements error. Yep, it does. So we don't need that anymore. And generics to the rescue. Excuse me. Okay, so we've cut down a lot of code there. Yeah. Okay, so now we have this. Let's look at, so query new takes that and the source, which is a stir source. And that returns, so we'll say with NIF error again, because we are potentially like query error, this implements error, so we're fine. Not the most ergonomic thing, but we'll at least be able to move forward more quickly. Okay, so we've created the query like we did over here. So we got the query. And then we want to do something like this. Except we're going to do a big Okay, so let's make a cursor new, and I think that that doesn't take any arguments. And right, so we have the tree. Then we do this goop. So that's the other thing, is that we need, this is the query source. One thing I neglected was we need the source content of the original parse, which is not great. The other option is that we have something that will implement that function type. Where did it go? So query cursor. So there was this text provider thing, right? And text provider has to return an iterator where the items are U8 slices. Yeah, so we kind of we need this, and I think that we needed it here anyway. So we're going to need that argument. And that means we need to change our NIF function here. So this is the source, and this is going to be binary, right? And then we need to do source.asSlice. And we can undo this because this returns a NIF result now. Okay, so now we have the source, and we can call, we don't need to call contents as bytes because it's already bytes. Okay, so let's call cursor. We're almost there, I promise you. Until there's like compilation errors because I've done something stupid. Okay, matches, and we give it the query. And we give it the tree root node, right? And then we give it the source. And then we're going to have to wrap this all in OK. Because if we got to this point, we know that it's going to return be a successful result. Okay, so returns. So inside here, the item we're iterating over is query matches. So the match, we're going to say query match from TS match. And we're going to pass M there. And we're going to pass query. And we're going to pass source. And collect. Oops. Let's get my stuff lined up here. That's okay. Get that on a separate line. Collect. Whew. Okay, all of that so that we could create Elixir structs. So what I want to do now is let's start working on the compiler errors, and then we'll wrap up the stream. Okay. So oh, interesting. Rustler Atom implements standard error. Fun. Okay. Well, let's comment out that implementation for now. Okay, start working through the. So, oops, I didn't put the schedule on there. So I need to fix that. That's an easy one. In the NIF, schedule is dirty CPU. Okay. So we fixed that. So this is, I haven't declared it, and that's probably a bad thing. I want to very explicitly import certain things. So tree sitter, we want query cursor. Rest of them can be inferred. Because those are the two things that we didn't declare. We didn't import. Okay, so we need 2vec on that. With a NIF error for enum result. Okay, so what I need to do is use create error star, and then we'll get that trait in there. Okay. So, fun. Okay. And I mistyped that. That was a typo. This is vec of query match. Okay, I need to fix that. There was a name issue there. Language. Okay. Oh, and I think I probably did it like this because to just make it clear that it's not the module language. Okay, so expected. Right, so, oops. Whoa. I hit Control or Command H instead of Command J. Okay, so here it's expecting to borrow that, so that's fine. Now the interesting thing is, I'm guessing from our query cursor, yeah, it returns this query matches struct. The type, yeah, so it's not iterating over references, right? So we could give it the whole thing, and here it doesn't need to be a reference, right? Okay. Cool. We are close. We are close. I promise. Okay, so that's fine. We remove the reference there, right? It says we're considered borrowing. We're not going to do that. Okay, so string cannot be indexed as U32. We did this in the other one. It's just usize. We need to do an as usize, right? So we'll say as usize. It might tell us we need to have an unnecessary clone there. We'll see. Expected usize found U32. Okay, so you know, in this case, since we're constructing it, I don't actually care that much. This can be U32, right? We don't care. We only care when we're trying to get something out of the list of captured names. Okay, and see any more of the errors. Expected string found stir. Okay, so line 93. Oh, right. So we need to do toString here, right? Because we unwrapped that. Okay. Now we will want to get rid of this panic. be and make it return result, and then like the parent thing return result of vec or whatever. So we'll need to fix that, but maybe we won't do that today. I'll leave that panic in. Right, so it's saying use text to string. Oh, that's fun. Okay. Doesn't satisfy into NIF error. All right. Well, let's clear that out, and I think I need to address this. Over here. Um, this is not pub, and it's not pub here either, because this is just wrapper structs. So I think I need to do impl deref for parser and for tree. Actually, we only need it for tree in this one case. So deref for tree. This is target is going to be this. And that's going to be self.0. That's a simple implementation that will get us around this issue of, hey, this is not, yep. What am I trying to say? That field is not accessible in that struct from outside. Okay. We're running out. So we need standard ops deref. Fine. Okay. And let's see what other errors. Okay, so oh, whoops. It needs to be and self-target. Okay, cannot convert mutex guard. Oh, so mutex lock doesn't return result. It returns lock result, which is result guard or poison error, right? So that's what I was trying to do. Okay, let's see what we did over here. Okay, so tree lock. Will return that lock result. What is the error actually saying? Okay, I've got some other problems up here. Right. But I thought it said Atom implemented error. Generics. Okay. Let's look at that real quick. Modules, types, Atom. Okay, so Atom does not implement error. So I should put that back. That's kind of weird that. And it's probably going to say I have conflicting implementations now because I can't have nice things. Right. Okay, so yeah, can't have nice things. Okay, so let's see if we can explain what it's running into. So I made this generic implementation of into NIF error. I said if anything is a standard error, right, we can convert it into the Rustler error struct, right? Um, by just calling format on self. Um, the but the problem is, I wonder if um, this atom and the top level atom are not. No, they're basically exposed. So it thinks that this implements error, but it doesn't. Um, because this is what we're trying to construct. We're trying to go, this implements encoder, right? Um, I wonder if there is some other bound that we can put on this that will make this not conflict. The other option is that I revert it and we implement this for each of those other things that we needed to implement it for. Um, yeah, that is really bizarre. Okay, so I hit Command H again. Okay, so I'm going to remove this and let's see. So we could either go on the fact that we need this or we need to do something else. We can just do map error on it in that one place that we call where it's complaining about atom doesn't satisfy NIF error. Okay, so with NIF error exists for enum, but its trait bounds are not satisfied. So right, so it's saying we haven't satisfied the trait bound on E, where E is an atom. Okay. So I think the answer is we do this rather than the other one. Right? And then we say type output is NIF result T. And then we say with NIF error self output. And we say self dot map error. And rather than calling this, we put a closure here. The error here is an atom, right? And so we could do what we were doing up here. We do this A, and I think that might fix it. Fun, new errors. Okay. Yeah, I guess it's that we're trying to implement it over Wow, this is really a pain in the butt. All right. This is good stuff. I'm really sorry we didn't get to see the end of this today. We're very close. We're just dealing with some orphan rule problems, um, and I probably might go revert this to what it was before and implement it for each type. Maybe we'll make a macro that lets us do it quickly, um, and then we can move forward, because I think that we're really close to getting the ability to call this from Elixir and then get a bunch of data about what was matched in a query. So thank you all again for coming, and we'll wrap it up now. If you have any questions, hit me up on social media. They should be linked from my Twitch stream. And we'll see you next time. Thanks.